Hi guys, sound. I've got a really cool project today. It's building a step sequencer. So it's going to be quite a long one. We're going to have to define a few classes or structs before we really get into building the thing. But if you extended what I do here, I'm sure you could come up with some really cool stuff. It definitely serves as the basis for lots of music making applications. So I won't dawdle too much. If you don't know what a step sequencer is, then probably best to have Google, or skip to the end of the video and have a look at the final product. But here goes nothing. So include the header file. And so yeah, we're going to have to include a few sort of data containers. So what have we got? We've got a step sequencer is just a sequence of hits or skips basically, or steps basically. So we need to make a class for each step, and then we need to put them all in another collection, which will be our sequencer, and then we want to have multiple sequences, so that then needs to be inside a vector itself. So we can start with the step, and I'm just going to, because I'm lazy, I'm just going to define it just under here. So do struct. I'm not sure if I should really be using a struct for this, but I'm sure largely it doesn't matter too much. Probably for coding style it's not great, but it needs an X and a Y position and a size, and whether it's on or off, so a Boolean value. Now I've come up with this sort of system beforehand, and this works for me, but you might have a much better way of sizing and laying them out. Love to hear any criticisms or thoughts on the general structure. But yep. So we need to have a render function. Doesn't have any inputs, and oh, actually it does. It does. And this is basically so if this is true, it means that currently this current step is the one that should be playing, because the playhead's over this step. So if this is true, we want it to be yellow. So we can do that by doing set color to 255,255,0. And then, so if that's not true, then we want to see if it's been selected on. So if the user has decided, well, I want this to play when the playhead goes over the top, and then if on is true, then we want it to be red. So set color to be 255. And then else, if it's neither of those, then we just want it to be white, because it's neither playing or it's neither playing or it's been selected. Cool. So then we just need to draw a rectangle and that's X and Y and size. And then we want also, what we need is a method to determine whether it's been pressed, or at least if this method is run, it will change the Boolean value. It's a little wrapper function, so we just do on equals not on. and all I'll do is say if this function is run, if on will equal false, then it will equal not false, which is true, or if on equal true, it would equal not true, which is false. So that's it. That's simple as that. Then we need to define another class, and this is our sequencer. So this is a bit more complex, but it's still fairly straightforward. We need a few values. We need an amount that's greater than 0, which is our step amount. We need a value for x and y, and also width and height, because remember it's sort of a collection of rectangles. Sorry, it's a collection of steps, squares, which will, all added up together will equal a rectangle. Then we also need to make a vector of steps. Call that steps. And then we actually need a sample, of course, for the sequencer to actually trigger when the step is on. So ofxMaxim sample. If you're not familiar with this, check out my tutorial on a simple sampler. That will go through the details of that. Let's call that sample. Okay, cool. So now we need to make a constructor, and what this is going to do is it's going to take some arguments and it's going to load the sample. It's going to add the amount of steps you want into the vector. It's going to push those to the back, and yeah, it's just basically going to size everything up for us and make it. It's going to initialize the whole struct for us. So we're going to do sequencer, and it takes float, so x position, y position, width, string, and a path. Step amount. And a gap. Now the gap is just the spacing between each step, so I think it just looks nicer. I played around for quite a while just trying to make that work nicely, and I think it does now. Not necessary, but you'll see it at the end, and it makes sense. So we have to set our step amounts. We need to load our sample. So sample.load, and then of2 data path. Remember to open up your project folder and put all your samples in the bin//data directory, and then this of to data path method will create a string with the right path, and it will append or concatenate your whatever you put inside as an argument to the end. So we want to load path. In fact, path isn't a very good name because it's not really our path. It's just the sample name. That's probably a better, because when we loop through in the main void setup for OVAP, we will have multiple samples, and we'll be passing through the sample's name as an argument. So I'll change that to sample name. Okay, cool. So then we need to do x equals x, y equals y, width equals width, and height equals width over step amount. So that will make sense as long as you understand what width of the sequencer is, and remember it's just a linear collection of steps. So we want to have squares for every step. So that the height, if you have 16 squares going along and you want to work out the height of that and keep that so they can all be squares, then obviously you're going to have to divide your long horizontal rectangle by the amount of squares that make it up. So that's what we do there. And then now we need to loop through and push back all the steps into our vector. So for int I equals 0, I is less than step amount, and I plus plus. And we need to make a temporary step, which will eventually push back to the vector. So, and then we set its size, so temp.size. Remember, these are all member fields of step up here. So temp.size equals equals height. So that's the width and the height of the square we want. X position equals we start off at the sequence's starting X position, and then we're adding whatever the current index is times the size here, plus the gap for each square as well, because obviously we want to have a gap. So that's I plus I times temp.size plus gap. So that will set the steps in the right place along the sequencer. Now the Y position just stays the same, so temp.y equals y, and temp.on equals false, so they'll be initialized to not be playing, and then we just need to push back temp to the vector. Cool, and then that exists. That's a thing right there. Okay, so what else do we need? We need to be able to rewind the sample that this sequencer is using. So let's make a little wrapper so it's nicer to call. So void rewind, and then that's sample dot set position to 0. And then we also need to be able to render the sequencer, or all the steps. So we can do void render, so yeah, current is just the when we call each individual's each individual step's render function, it takes a Boolean argument, and we want to have an if statement in here saying if, when we loop through every step, we want to say if the current step equals the current one that should be playing, then pass in a true argument, else call the step's render function with a false argument. So that's exactly what I will do here. So for int I equals 0, I is less than step amount, I++, and then if I equals current, then render with a true. Simple as that, really, and that's everything constructed. Good to go. So now we just need to sort out the rest of our header file. We need to have an audio out method. And what else do we need? So we're going to need to build a timer. I think I've done a timer before. That's in the FFT video, in case you're not familiar with that. So we're going to need everything for that. We're also going to need buffer size, sample rates, step amount. Right, okay, so unsigned. None of these can be less than 0. So these are more sort of render values. So step size, sequencer X, sequencer Y, and sequencer width. Then we need our values for audio output. So double frequency, current sample. Actually, why the hell do you want a frequency? Don't need that. We're using samples. And we need our maxi mix. And what we're going to need is we need a vector of sequences. And I found it was a lot easier just to have them all as pointers. So we need a vector of pointers. Now that, yes, again, it's easier just to make them unique pointers, and that's a bit of a mouthful. You know, a vector of unique pointers of sequencer is definitely a bit of a mouthful. So we can do a type definition at the top. Let me just do that by type def, and that just allows us to name a type for our own nefarious needs. So vector unique pointer PCR, and that's of sequencer. So that's how we can have a vector of sequences. Close, and we'll call that seq collection. So then down here, when I want a vector, I want to declare my vector of unique pointers of sequences, then I can just do seq collection seeks, and it knows what I'm on about. Well, it doesn't really, because my computer's struggling to catch up and it doesn't have time to index, but that's fine, we will soldier on. So we need to set up, let's keep everything at a consistent frame rate of 60. If it can, it will attempt to do that, so we can do that by doing of set frame rate to 60. Sample rate equals 512. No, that's a complete lie. That's 44,100. Buffer size equals 512. And let's set the background to black. We'll see that through the spaces are a gap. So set up the DAC. So of sound stream setup, and when you want 2 outputs, 0 inputs, a pointer to the base app, sample rate, buffer size, and 4 buffers per channel, or 2 buffers per channel, I think. Okay, so we need to initialize our timer that we're going to make. Again, if you're not familiar with timers, check out the FFT video. There's more on that. And also, if you're not familiar with multiple oscillators or sound making devices, there is a video for you, but I'm not entirely sure which one that is. Or you can just watch on and see me do it anyway. It doesn't really matter, they're all fairly independent of each other. So we need to initialize our start time and initialize that to the elapsed amount of time since we started the program. So of get elapsed, is it 2 L's? Yes, one L. Elapsed time minutes. Won't like that space. Cool. And we want to have our tempo in. It's not really a tempo, but you could work out how to make that a tempo, I'm sure. We'll just have that so the timer retriggers, or the size of the timer is half a second, so 500 milliseconds. So we just do end time equals 500. So that's cool. What else do we need? We need to decide how many steps we're going to have in our step sequencer. Usually it's a multiple of 8 or 4. I'm going to go with 32. You can do whatever you want. Step size, step amount. It's 32. And initialize sequencer X and Y. It's telling it to draw the sequences from 0, 0. We're going to make sequencer width. Sequencer width equals the size that we've set in of main. So that's 400 wide. So that's of get width. and then step size, we want that to be get the width and divide it by the amount. So if in this case it's going to be 400 divided by 32. And then we also need to set our gap. So gap equals 2. Okay, cool. So that's looking pretty good. Next, we're going to need to load up all of our sequences. I need to push back unique pointers of sequences into the array that we've handily named or declared a type called seq collection. So what we can do, I've got 5 samples in my data folder, so I'm going to do 5 sequences. This could easily be extended to however many samples you've got, or whatever. You know, you don't have to use samples either. You can make this trigger oscillators or whatever. You know, this is just the basis, and you could quite easily extend this in quite interesting ways. So we can do for unsigned I equals 0, I is less than 5, I++, and we need to make a file name that we can pass in to the object, so the sequencer object. So when it loads, because one of the arguments to the sequencer constructor, it asks for the file name, so it can load that, whack that in the data path of data path method. So it's quite simple. Just make a string stream s, so declare that, and then we do s, and then so we're going to pass in my case, my files are all named 0.wav, 1.wav, 2.wav, 3.wav, 4.wav, provided that they all increment. They stay consistent in terms of the letters, and they just have a incremented number. Then there's a way to sort of just use the current index in the name. So I'm just making this string, or this buffer of characters, and concatenating the number, the current index, and .wav. And then, oh, in fact I don't even need endl. And then I can use that as an argument. So what I need to do is do seeks dot pushback, and the arguments are the x position, y position, width, string path, step amount, and the gap size. So I can do. So I need to push back and unique pointer of sequencer type, open brackets, then push that back to the heap. So new sequencer, and I want these to incrementally go down as I make them, depending on the index. So I can do sequencer y plus I times step size plus the gap. So that's x and y position taken care of. Then need to pass in the sequencer width, and we need to pass in the name of the file. Now we can't just write s. It's not technically a string yet, all you need to do is type s dot to, no, it's just s dot str, and that will supply it in string format. And then the next argument is step amount. So I just pass in step amount, and then pass in gap. Cool. So that's sorted. So we've loaded up all of our sequences. Then we just need to set the playhead current to 0. And then I've added an extra function in to resize the window, because after you've added a gap to make your steps stand out from one another, when you add up that gap and multiply it by the step size, you'll find that your sequencer, the last step is actually after the height, or the width, the full width of the screen. So we just need to resize it to the right amount. So we do of set window shape, and that's step amount plus 1 times step size plus gap, and then for the Y position we need to set it to seeks size times step size plus gap. And that's really straightforward. We're just basically making it wide enough and tall enough to accommodate our sequences. Okay, so let's take care of the timer. Now this is going to deal with currents for us. So basically, if timer is greater or equal than end time, or if the current time is greater or equal than the timer length, then we want to increment the whatever the current is pointing to, the current playhead. So, and then also we need to rewind. All of the sequences as well, to have them ready to be played again. So basically, all we need is to make our current time. So current time equals of get elapsed time minus minus start time, and then if current time is greater or equal to end time, then do something. Now what do we want it to do? We need to increment current. So it's our current thing that we're pointing at, the current step we're pointing at to increment. So current equals plus plus current, and that's just for order of precedence. We want this thing to increment first and then to be moduloed by the amount of steps, so we don't get a bad access error. Then we need to loop through all of the sequences. I'm going to use an iterator, so I need to make an iterator. So for seek collection, remember that's the type we defined. Iterator, and we'll call the iterator it. It points at the beginning of the vector, and we want to, oh, that's bad syntax, so make it, initialize it to points at the beginning of seeks, and the test condition is we don't want it to equal end, so, or if it does, then end, and then increment the iterator. So then for every sequencer we just want to rewind. Now the thing is, you can't just write it dot rewind. Remember, this rewind function we defined in our sequencer. Gap. Let's use that. Yeah, we can't just call this because firstly, the iterator itself is more or less a pointer, and also the vector is a vector of pointers. So we're going to need to dereference this twice, basically. So yeah, you can dereference it different ways, but I'm just going to do this. So firstly, we dereference the iterator. So it's now equaling. If it was just that, then we'd have the current object, but it would be still a pointer. We dereference the pointer, or access the member method like this. Cool. And after we've incremented the current playhead and rewinded all the sequences, then we can set the timer to the current, or the current time to the, no, sorry, we can set the, what is it? Yeah, we can set the start time of the timer to the elapsed amount of time, millis, reset the whole thing, and then it will keep on going. So start time equals of get elapsed millis cool. Then down in draw, we want to iterate through the vector of unique pointers, sequences, and draw them or render them. So it's quite simple. We just copy that and change this method to what's the method called? To render. And remember, render takes an integer argument or an unsigned int argument. And that's the current playhead, so it can render the correct steps, whether they should be yellow, red, or white. So we just input current into this. Okay, cool. So I peskily didn't include or delete my audio out method, so that's already done for me. So what do we need to do? We need to loop through the buffer size, and we need to firstly initialize our current sample double value, and then we're going to tack on each sequencer's sample object value on the top of it, if the current step should be playing. So that's all a bit of a mouthful. So I'll just show you what I mean. So let's loop through the buffer, of course, as usual, first. So we need to initialize the current sample to 0. And this is important. If we didn't do this, then each time the buffer iterated, this index here incremented, current sample would tack on more and more sample values, and I presume it would just crescendo into this huge noise, probably blow your speakers. I'm not really sure what would happen, but it wouldn't be good. Whatever happened, don't do it. And then we need to iterate. So it's a nested loop, basically. We need to iterate over every sequencer, and we need to return basically its current sample. If we're playing the not current sample, but its current frame of its sampler. So I'll show you what I mean. So current plus or equals, so dereference the iterator, and then dereference the pointer that the iterator is pointing to. And then each sequencer has a member object called sample. We want to play once, and that's going to return a double to be added into our current sample. And then the really important thing to do is to divide whatever we're adding onto the current sample by the size of the vector of sequences. Otherwise we'll get a really loud sound that will again burst our speakers. That's bad. So we just do seeks.size. Okay, and then we just need to actually no, we need to do something else. So the problem we've got here, I've noticed a problem. Every time this is basically not going to work as we want it to, because it's going to try and play on every step increment. We don't want that. So we actually need to include a if statement. So we can go if the current step is on, so dereference the iterator, and then get the vector of steps. So and then the current one is that, and then the value of our so each step has a on bool member field. So if that is true, and we can I could type it explicitly like that, but if you're checking for true statements, then that's equally as valid. So if that is true, then run this. So if the current step has been selected by the user, then play the sound, basically. Okay, so we need to then we've added concatenated, or summed all the sample values into one double, which is our current sample. Now we need to route current sample into a stereo mixer, and then that will route into our outputs array, which then can be routed into our output float of our output float array, which is our buffer. So we just do mix.stereo, and 0.5, and then output I times number of channels that equals output 0. And it's plus 1. Okay, awesome. Dare I say it, that's sorted. Although it's not sorted, is it? Because there's no way of selecting what sample, what step we want to play, or triggering whether we want to, there's that particular step to play or not to play. To play or not to play? That's the question. So we need to, in mouse pressed, we need to work out the index from our position, and then run the correct function, the pressed member method of each of the step that our coordinates point to. So I'll just type that out. So unsigned ypos equals floor. We use floor because arrays are 0 indexed. So we want to make sure that we're always pointing to the value below. So y over step size plus gap. That's fine. Unsigned x pos equals floor float x over of get width times step amount. Okay, cool. So we've got our y and x index. So essentially what we're dealing with here is a two-dimensional vector, sort of. So the y position equates to our sequences. So which sequencer are we accessing? So we do seeks ypos like that, and then we need to, because it's a pointer, we need to access it like that. We need to get now our steps vector and input the x position, and then inside the step that we're pointing to, we need to run its pressed method, and that will trigger its on equals not on body. Cool. Let's give it a go and see what happens.
Go!
Okay, expected. So it doesn't like one of these because it's between a float and a float. Well, current shouldn't be a float. So how have we declared it? Declared it as an integer. So why does it think it's a float? What else have we got? Okay, so we are missing our double outputs array. It also thinks current is a float. Current equals current step size. Okay, so that's a problem there. Well, why is that a problem? Oh, of course. That's step amount, not step size. Should probably name my variables better. Let's give that a go. Awesome. So yeah, looking fairly positive. Just have to give my computer a bit of time just to struggle and get it done. Crunch through the numbers. But yeah, this can be extended in lots of different ways, and you don't have to use samples, and you don't necessarily have to. You could have a two-dimensional array, or sorry, vector of sequences, or you could sort of turn into more of a sort of note arrangement sequencer with a few tweaks, really. Just let it load. Cool. Okay, so I can do that. Load some samples in, make it perhaps a bit faster, the tempo is a bit slow, but there you go, a working step sequencer that you can use. So I hope you enjoyed it. Best, take it easy. Sound. Bye.